Hi, in this video, we are going to do an introduction to the carbonyl containing functional groups. So a carbonyl is a carbon double bonded to an oxygen with two single bonds to other atoms or groups. The carbon atom center, so this carbon in the center, has a trigonal planar geometry. Many biological molecules and intermediates of metabolism contain these functional groups. They are very important in biochemistry and organic chemistry. One single bond of carbon is usually a carbon-carbon bond, or a CR. R means the rest of the molecule. The other single bond identifies the functional group. So we have aldehyde, where we have a CR group right here. The carbonyl, which is the C double bonded to an oxygen. And then the atom to look at is the other one. Which atom is the carbon bonded to? Which other atom is the carbon bonded to? For an aldehyde, it's bonded to a hydrogen. For a ketone, it's bonded to another R group. For carboxylic acid, it's bonded to another group. And the group it's bonded to is a hydroxyl group or an alcohol. So it's OH. For an ester, it is bonded to an OR group. For an amide, it is both bonded to a nitrogen, which is bonded to either a hydrogen or an R group, or a hydrogen or an R group. So it's bonded to either two hydrogens in an R group, one hydrogen in an R group, or two R groups. So a group, a carbonyl containing functional group, the group is the carbonyl group plus the atom or group bonded to it. So for a carboxylic acid unit, this whole group acts as a unit, not two separate units as a carbonyl group and a hydroxyl group acting separately. They act together as a unit. The carbonyl group is polar covalent bond. It has a carbon. Carbon is partially positive and oxygen is partially negative, and therefore there's a permanent dipole. All carbonyl containing groups have dipole-dipole intermolecular forces of attraction. Some have hydrogen bonding if there's an OH or NH group on there. So for carboxylic acids, we have an OH group, and therefore it has hydrogen bondings. For aldehydes that have an R, C bonded to the carbonyl, bonded to the H, there's no OH or NH group right here. Therefore, it does not have hydrogen bonding. So in summary, carbonyl containing functional groups contain a carbon center with a carbon double bonded to oxygen and bonds to two other atoms or groups. One of them is usually an R group, or the rest of the molecule usually contains a carbon atom and then the rest of the molecule. The atom or group on the other bond distinguishes the functional group. The carbonyl group has a permanent dipole and dipole-dipole intermolecular forces. And some carbonyl containing functional groups have hydrogen bonding if they have an OH or NH bond in their group that they're bonded.